Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 physics alternating current, chapter 7 ncert solution, part 8. Please subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Today we'll start with question number 7.19. Suppose the circuit in 7.18 has a resistance of 15 ohm. Obtain the average power transferred in each element of the circuit and the total power absorbed. We'll solve this sum in 5 steps. First step, summary of all the physical quantities given in the problem sum. We'll write those. Step 2, we'll find the value of impedance. The formula is Z is equal to under root R square plus omega L minus 1 upon omega C whole square. Step 3, we'll find the value of I in the circuit, the current in the circuit, by putting I is equal to V upon Z. Step 4, average power I square is equal to R. Step 5, total power. We'll find the power individually with respect to resistance, inductance, and uh, the capacitor, and resistance, inductor, and the capacitor. Then we'll add it all the three power for all the three, and we'll get the value of total power. So we are in the first step, writing all the value of the physical quantities which are given in the question. So inductance of the inductor L is equal to 80 mH, which is given in the question, which is equal to 80 multiplied by 10 to the minus 3H. Capacitance of the capacitor C is equal to 60 microfarad, which is equal to 60 multiplied by 10 to the power minus 6 farad. Resistance of the resistor R is equal to 15 ohm. Now, potential, we'll find few more things are given, that is potential of voltage supply. V is equal to 230 volt. Frequency of signal, frequency of signal nu is equal to 50 hertz. Next, angular frequency of the signal, signal omega is equal to 2 pi nu. which is equal to 2 pi 50, which is equal to 100, which is equal to 100 pi radian per second. Now the element are connected in series to each other to each other. Hence, impedance impedance of the circuit is given as Z is equal to under root R square omega L minus 1 upon omega C whole square. Now putting the values here, we get 15 square plus 100 pi 80 multiplied by 10 to the power minus 3 minus 1 upon 100 pi multiplied by 60 multiplied by 10 to the power minus 6. So this bracket little big so that we can put the whole square here. So upon solving, we got 15 square plus bracket 25.12 minus 53.08 whole square, which is equal to 31.728 ohm. After the after getting the value of impedance Z, we can find out the value of the current in the circuit, that is V upon Z by the formula V upon Z, that is 230 and 31.728, which is equal to 7.25 ampere. Now average power transferred to the resistance to the resistance is given as PR is equal to I square R, which is equal to 7.25 whole square 15. Upon solving, we got 788.44 watt. Now, average power transferred to the capacitor. Power transferred to the capacitor PC is equal to average power transferred to the inductor PL is equal to 0. Total power absorbed BED absorbed by the circuit is equal to PR plus PC plus PL, which is equal to 788.44 plus 0, which is equal to 788.44 watt. Hence, the total power absorbed by the circuit is 788.44 watt. Let us see the next question. Now we'll solve question number 7.20. A series LCR circuit with L is equal to 0.12H, C is equal to 480 and F R is equal to 23 ohm is connected to a 230-volt variable frequency supply. A. What is the source of the frequency for which the current amplitude is maximum? Obtain the maximum value. B. What is the source of the frequency for which average power absorbed by the circuit is maximum. Obtain the value of this maximum power. C, for what or for which frequencies of the source is the power transferred to the circuit. Half the power at resonant frequency. What is the current amplitude at these frequencies? D, what is the Q factor of the given circuit? Let us see the solution. So 7.20 or 7.20 steps will be: step 1 is write the summary. Write the summary of the sum. Now means all the given values, known values in the sum. So step 2 is find the V naught. Find V naught. Step 3, which will be A part, which will solve the A part. So step 3, or write it in this way here, A part. Now we'll solve the A part. So step 3 for A part, first we have to write the use the formula uh, this and find out the value of I naught, that is R square. You have to remember this formula. Without this formula you can't solve this sum. So omega L 1 upon omega C whole square. Now in the next step we can write, we have to find out the value at resonance, what are the conditions, those are there. So we'll see this when we'll solve the sum. So step 4 is important for to find out omega r, which is 1 by under root LC. So and step 5 is resonant frequency. So VR is equal to omega r upon 2 pi. Just follow this formula, and when everything will be found, then we can write in step 6 we can find the value of I naught max, which is V naught upon R. So these things we have to find, these steps we need to follow to find out the answer. Now our A part is completed. Now comes the B part. So step 7 to solve the B part is just you have to remember this formula. Then B part will be solved. P average max is equal to half half is equal to half I naught max square R. Next is part C. Step 8. Step 8 is just you have to remember the formula that for power transferred is equal to omega r plus minus delta omega, or we can also write 2 pi omega 2 pi nu. So 2 pi you have taken comma nu plus minus delta nu. So nu r, and putting the values we can solve the sum. So let us see the solution of the sum. So first step was we shall put all the values which are known to us. So let us see which of the values are known. So inductance L is equal to 1.12 H. Capacitance C is equal to 480 Nf, which is equal to 480 multiplied by 10 to the power minus 9 F. Resistance R is equal to 23 ohm. Supply voltage V is equal to 230 volt. Peak voltage is given as V naught root 2 V, which is equal to root 2 multiplied by 230 volt, that is 230 root 2, which is equal to 325.22 volt. Now A part. So we have written all the given thing, and we have also find out the peak voltage. Now A I naught is equal to V naught upon under root R square plus omega L minus 1 by omega C whole square, which is equal to, where I naught is equal to maximum at resonance. maximum at resonance. At resonance, we have omega R L minus 1 by omega R C, which is equal to 0, where omega R is equal to resonance angular frequency. Resonance angular frequency. Omega, therefore, omega R is equal to 1 upon under root LC, which is equal to 1 upon under root 0.12 multiplied by 480 multiplied by 10 to the power minus 9, which is equal to 4166.67 radian per second. Therefore, resonant frequency Vr is equal to omega r upon 2 pi, which is equal to 4166.67 upon 2 into 3.14. Upon solving, we get 663.48 Hertz and maximum current I naught max is equal to V naught upon R, which is equal to 325.22 upon 23, which is equal to 14.14 ampere. Now let us see the next part, part B. Maximum average power absorbed by the circuit, that is P average maximum, is equal to half I naught square max R, which is equal to half 14.14 whole square 23, which is equal to 2299.3 watt. Hence, resonant resonant frequency. Frequency VR is 663.48 Hz. Now we'll see part C. So part C, the power transferred to the circuit is half the power at the resonant frequency. So the power transferred to the circuit is half the power at resonant frequency. Frequency. Frequencies at which frequencies at which power transferred is half is half is equal to omega r plus minus delta omega, which is equal to 2 pi nu r plus minus delta nu. What you have done here, omega is equal to 2 pi nu, so you have converted into 2 pi nu and you have taken 2 pi as a common. So where delta omega is equal to r upon 2l. You have to remember these formulas. So where so put the value of r and l, so we get 23 upon 2 multiplied by 0.12, which is equal to 95.83 radian per second. Hence, change in frequency delta nu is equal to 1 upon 2 pi delta omega, which is equal to 95.83 upon 2 pi, which is equal to 15.26 Hz. So nu r plus delta nu is equal to 663.48 plus 15.26, which is equal to 678.74 Hertz. Now delta nu r minus delta nu is equal to 663.48 minus 15.26, which is equal to 648.22 Hertz. Hence, at 648.22 Hertz and 678.74 Hertz frequencies the power transferred is half. Is half. Now at these frequencies current amplitude can be given as I naught is equal to half 1 upon root 2 multiply by I naught max, which is equal to 14.14 under root 2 is equal to 10 ampere. Now the D part. Q factor of the given circuit can be obtained using the relation Q is equal to omega R L upon R, which is equal to 4166.67 multiplied by 0.12 upon 23, which is equal to 21.74, which is hence the Q factor of the given circuit is 21.74. answer. This is the end of today's session. Please subscribe, like, and share our YouTube channel. And please click on the subscribe button to support us. And also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Please give a like, sunshine, who have already subscribed to our channel. Thank you for your support. Let us see you all in the next class. Thank you.